Alright, today we are going to open up the transformer, the architecture behind GPT, Gemini, Claude, and basically every modern AI LLM. And instead of abstract math, we'll use this amazing visualization to see every step happening live. By the end, you will understand exactly how a transformer processes a sentence. We do have this example. Data visualization empowers users to create, and the first step is the tokens that turn into numbers, so the embedding column. The first job of a transformer is to turn words into numbers. The model can't understand text directly, it understands vectors. So that's why the tooltip shows vector 768. So this vector has 768 numbers. Each word gets turned into a point in a high dimensional space. Similar words end up in similar places. This is the model's learned understanding of meaning. Just some analogy, you can think of it like GPS coordinates, but instead of a map, it's a semantic map. The second step is the positional encoding. As you can see, we have these stripped bars. Transformers have this one problem. They see all words at once, so they don't know the order. These stripes encode the position of each word in the sentence. They get added to the embedding so the model know both what a word is, where it is in the sentence. It's like giving each word a tiny timestamp. And then it goes straight into this query key value. Next, each word puts on 3 hats, query key and value. Point to Q, which is blue, K, which is red, and V, which is green. Query is like what this word is looking for, key, what this word offers, and V, the value, the information this word carries. This is like every word walking into a room and asking, oh, who should I pay attention to right now? All these Q, K, and V vectors come from a simple operation, embedding multiplied with weight matrix, as you can see in this visualization, plus the bias. No magic, just linear algebra. The model learns these weights matrices during training. Now you can see this purple matrix. Attention starts by comparing every query to every key. This is done with a dot product, as you can see in the matrix. Let's wait a bit for this visualization. High dot product means these words are related. Low means they are not very relevant. It's like measuring how similar two arrows are pointing. Then we have this scaling and masking. These scores are then scaled down to keep numbers stable. If the model is generating text, we also apply a mask so it cannot look at future words. And the third step is softmax. Softmax turn those scores into probabilities, the actual attention weights. Darker circles mean stronger attention. It's like saying for this word, here is who matters and how much. The model now uses those weights to mix the value vectors. The result is a new representation of each word enriched by context. Then we have multi-head attention. You can see that we are now at head 7 of 12. One attention pattern isn't enough, so transformer use many heads at once, 12 here in this case, as it is a representation of GPT-2. Each head specializes in a different pattern, like grammar, relationships, meaning, structure. The model then combines them. We then go into layer normalization. Layer norm keeps the model stable. It normalizes the activations so the network stays healthy and easy to train. After attention, we pass each token through a small neural network. That's called the MLP. First, let me go into this. First, it expands the vector from 760 dimensions to 3072 matrix. This lets the model create richer nonlinear combinations. Then it shrinks the vector back down. We also add residual connections to skip paths that let the model keep all the information. They help gradient flow and prevent information loss. Next, it goes into stack. All of this is one block, transformer stack. Many blocks, 12, 24, 96, depending on the model. More layers usually mean more reasoning ability. And at the end, we have the logits and probabilities. Let me click on one. The final hidden representation is converted into logits, which are raw scores for each word in the vocabulary. Softmax turns logits into probabilities. The model believes the next word is more likely visualize. And I want to explain to you why the highest probability word is not always picked. This is something important that you should have in mind. The model doesn't always choose the top word because deterministic models become boring and repetitive. That's why we do have a temperature slider plus top case selector. Temperature adds control randomness, while top case sampling restricts choices to the best candidates. This lets the model stay creative, surprising, and human-like. It's just like rolling a weighted dice where better words have higher chances, but nothing is fixed. And that's the whole transformer, from tokens to embeddings, attention, MLP, repeated many times, probability distribution to next word. Simple parts arranged in a brilliantly scaled way, and when you scale it up, you get GPT-4o, Gemini, Claude, everything we use today. Thank you so much for watching. And do let me know if you enjoyed this type of video so I can make more.